Hello everyone and welcome. Today I'll be talking about current divider and voltage divider rules used in electrical circuit analysis. So let's get into it. So for the learning objectives, after this you should understand voltage dividers, understand current dividers, learn how to apply the formulas and also to solve some basic problems. So voltage divider rule. What does this rule explain? The voltage divider rule tells us how the total voltage from a battery or a power source gets split between resistors when they are connected in series. The voltage across each resistor is directly proportional to its resistance. Okay, so basically you just explain how current that flows into a circuit, how voltage from a battery or a power source that flow into a circuit get split between resistors when they are connected in series. So just to note, the voltage divider rule is used only when resistors are connected in series. Okay, here's an analogy to explain. Imagine you have a big pizza, right? And this pizza is supposed to be shared between two people. One person have a huge appetite and one person doesn't really have much appetite. So the person that has a bigger appetite is going to eat more pizza than the person who doesn't really have that much appetite, right? So similarly, the bigger resistor is going to get more voltage than the smaller resistor. So basically that's just what the voltage divider rule helps us to solve. And it's also important to know, like I said earlier, that this rule only applies to resistors when they are connected in series. So you cannot apply this when resistors are connected in parallel. Okay, so for the general formula, it is Vx, which is like the voltage we are trying to calculate, is going to be equal to Vs, which is the voltage from the source, power source or battery, multiplied by Rx on R total. This Rx, I put R, it's supposed to be Rx. Rx for the resistance we want to calculate the voltage across. So it's going to be Vx is going to be Vs, which is the voltage from the source, Rx divided by R total. So that is how we're going to calculate the voltage flowing across the resistance Rx. Let's get into it. So now, this is a sample circuit explaining the rules. So here we have R1, the voltage across R1 is V1. We have R2, the voltage across R2 is V2. And we have Vs, which is the total, the source voltage, right? So, in order for us to calculate the voltage across resistor R1, which is V1, we're going to have V1 is going to be equal to the source voltage or the total voltage multiplied by R1 divided by the total resistance. Since they are in series, the total resistance is going to be R1 plus R2. So we're going to have Vs multiplied by R1 divided by R1 plus R2. That is going to be the voltage across the resistance R1. And for the voltage across resistance R2, we're going to apply the same format. We're going to have V2 will be equal to Vs multiplied by R2 on R total, which is R1 plus R2. So basically that's the explanation. And for the general formula, for any resistor Rx in series, Vx, which is the voltage that flows across resistor Rx, is going to be equal to Vs, which is the source voltage, multiplied by Rx on the R total, where R total is R1 plus R2. So that is the explanation. And let's say in this case we have Vs equals to 12 volt, R1 4 kilo ohm, and R2 8 kilo ohm. And we need to calculate. We're just going to put in the values. We're going to have 12, which is a Vs multiplied by, for V1 we're going to have 12, which is a Vs multiplied by 4 for R1 divided by 4 plus 8, and we're going to have our total voltage of 4 volt. And for V2 we're going to do the same. Vs 12 multiplied by R2 8 divided by the total 4 plus 8. We're going to have a total voltage of 8 volts. So you realize that since R2 has a higher resistance than R1, the voltage across R2 is going to be higher than R1. So now let's talk about current divider rule. So what does the current divider rule explain? The current divider rule tells us how the total current is going to be split between resistors when they are connected in parallel. The current through each resistor is inversely proportional to its resistance. So, like, to give an analogy or a simple example, so let's have like a big river, okay? Imagine a big river of water that splits into two parts. Most of the water flows through the wider part and the easier part. Similarly with current, the part that has less resistance is going to get more current than the part that has more resistance. So for the formula for two resistances in parallel, for us to calculate the current that goes to resistor R1, we're going to have I1 is going to be equals to I total multiplied by R2 divided by R1 plus R2. That's the general formula. So this is a circuit. We have Vs, which is the voltage, the total source voltage, It, which is the total current. Then we have I1, which is the current that flows across resistor R1, I2, current that flows across resistor R2. So in order for us to calculate the current that flows across resistor R1, what are we going to do? We're going to apply the formula. I1 is going to be equals to I total, which is the total current multiplied by R2 divided by R1 plus R2, and there we have it. Same for I2. I2 is going to be equals to I total multiplied by R1 divided by R1 plus R2. So basically that's that. And if we have values like the total current is 6 amperes, the resistor R1 is 4 ohm, R2 6 ohm, find I1 and I2. We are going to have I1 to be equals to, we know the formula already, you just substitute. It is 6 amperes, R2 6 ohms divided by R1 plus R2, which is 4 plus 6. That is going to give us a total current of 3.6 amperes. And we are going to do the same for I2. 6 amperes multiplied by 4 divided by 4 plus 6, we're going to have a total of 2.4 amperes. And what are you going to realize from this? You're going to realize that the current flowing across resistor R1 is greater than the current that flows through the resistance R2. And why is that? It is because the resistance R1 has less resistance than resistor R2. So basically that's just the explanation of the current divider rule.